One thing that's almost impossible to prevent in software is the fact that software is unexpected. Our software will fail, it will misbehave, and it will act in ways that surprise us. And by default, if we don't do anything about it or take any proactive measures about it, then when something bad happens, and it definitely will happen, we won't know about it until a customer complains or until it's just too late. It's like, imagine if you were trying to set up a factory, only not to have no security cameras, no motion sensors, and not even smoke detectors. The entire building could be up on fire for the whole night, and you wouldn't even know until the next day. And we see these kind of fires all the time in software, right? I'm sure you've seen those yourself, you've experienced those yourself, maybe even you experienced those today. And this is where observability really shines and really helps solve. And we see it all the time. One of the recent surveys that came out called the State of Observability Survey 2022, and it found out a few amazing things. It surveyed over 1,000 companies, and what it found out is that companies that used observability for over 2 years had 69% faster mean time to repair, so that means that they solved issues way faster, and they had 60% more products or revenue streams. So not only they solved issues faster and they detected issues faster, they actually launched 60% more products. And these are the kind of benefits we can see with observability. But what is even observability? So observability comes from the words observe and ability, and the meaning itself means to see something. But in software, what it usually means is that it means and refers to any tool that helps you track the internal state of your system better. So if a tool helps you do that or monitor your system, it could be counted as an observability tool. Now, it's a pretty wide definition, but at the end of the day, all observability products and technologies mostly come down to two main things. First, they're about data being sent. So our systems send a lot of data that's important to us. And then they're about data being analyzed. So after we send that data, we analyze that data and use it for useful conclusions. So I invite you on this journey with me today. And what we're going to do is that we're going to take a simple, plain Node.js service, and we're going to completely transform it with the power of observability. In fact, we're going to implement something that's called the 3 pillars of observability, which are logs, metrics, and traces. And don't worry if you don't know what they are right now. We are going to cover them, and we are going to implement each and every one of them. But for now, you can think of them as different types of data. Cool? So starting with the first part, logs. So what is a log? A log is essentially a record that stores information. So usually it's a JSON object, but you can store any type of information you want in a log. It could be numbers, it could be dates, anything that's useful to you. And before we showcase the live demo and everything that we did, I want to tell you about Stockly. And Stockly is the app that we'll be showcasing. It's a completely made-up app for this tech talk. And what Stockly does is that it's kind of like Robinhood, if you've ever heard of the app. It allows you to purchase stocks from your favorite companies. So if you want to buy stocks from Google or Facebook, you can do that. And what we'll do today, in the first part, in the logs pillar, we're going to use Kibana and ElasticSearch. It's going to look like something like this. And later, we'll add some graphs and visualizations, and it's going to look like this. So without further ado, so just a quick explanation about what we see here. It's a simple Express application. We have an orders route right here. That orders route has a route called order stock, which allows us to buy stock. It doesn't have any real functionality, just a function called savingDB, which pretty much does nothing. So that's the first simple application. Now, the way the talk will be divided is that we're going to take each and every one of those pillars, and each and every one of them is divided into a branch. So we have the first branch called adding logs, second one is adding metrics, and third one adding tracing. Let's go to the first one and see what we added there. So I'm going to check it out. Good. And the first thing I want to show you is the actual infrastructure of the project. So we have a Docker Compose file to set up all the dependencies we need, simple setup script, Elasticsearch, and Logstash, Filebit, and Kibana. We use Elasticsearch for the database itself to index and store logs. Elastic works great for that. We use Logstash and Kibana to actually send the logs to Elasticsearch. we use Logstash and FileBeat to send the logs to Elasticsearch, and we use Kibana to actually visualize those logs. So that's what we added on the infrastructure level. Now let's take a look at what we added when it comes to the code itself. So we have a logger here. I use Pino for this. We have a lot of loggers out there. You could use Banyan, Winston, whatever you prefer. And what we have here is a simple logger with two streams. First of all, we're writing all the logs to std out, so we're writing it to terminal. And the second thing is we're writing all the logs to a file. So if you remember, we saw FileBeat and Logstash before as dependencies. What they do is that they go and scrape that file for logs and then send it to Elasticsearch. OK, so we have some logs now, and we can look at the application. And I'll actually show you the logs that I added in the route itself, because I did add some manual logs to make things easier. And if I go to orders control, you see we have 3 logs now. Also added some mock data here, but the main 3 logs is the first log when the user is trying to place an order. We're logging it out along with the user and the order. The second log is if the order was successful, then we log that again, but change the state to successful. And if it failed, then we change the state to failed and log that again. So we have everything set up. Now let's see how we can actually see that in Elasticsearch. First thing I'm going to do is that I'm going to go to Kibana. And what we see here in the Discover tab is now we see all the logs that we have, all the general logs. Now, by default, that contains a lot of default logs and infrastructure logs that we don't really care about. So let's filter it out to use our logger. And now we filter it out to use the logger Stockley. So we don't have any logs right now. Let's make some HTTP requests so we can see those coming in. Just making some requests. Those are purposely failing. And some ones here. Great. Now wait for a few seconds, refresh. And now we're seeing all the different logs. So we can start customizing this screen and this grid. We can, for example, add the state here and add the email here. And now we can see all the emails and all the logs that were successful or not successful. But the powerful thing here really is the filtering capability. Because if you try to go and look at the logs yourself or the exception yourself, it's something that's first really hard to read, and second, lacks a lot of context. So you get a lot of context here, but you also get the ability to filter. So one thing we can do, for example, if you notice there is an order that failed for this user, we can filter and look for the specific user's logs. So if I filter for the user email, now I can see only that user's logs. And this is pretty powerful because what you saw right now in the code was simply 2-3 steps maybe of a journey that a user goes through. But in real life scenarios, it's many more steps than that. So when you want to debug something complex and you're adding context to every step, you can simply search by the email. And email is only one thing you can think of. You can add more and more filters and filter however you want. So I'm going to let your imagination take the rest of what you can do with it. So that's our filtering capabilities. And the second thing that we can do right now to really take it up a level is to actually add a dashboard. So I added a dashboard already. And all the dashboard you see here, which gives us all kinds of operational and just even business statistics, are, for example, median price of order, or how many orders were successful, or what is the order by credit card or by country. All of this that you see here was generated from those 3 simple logs that I showed you before. So it's pretty easy to create dashboards once you have logs. We added Elasticsearch, we added Kibana, and we saw right now how we can centralize everything into one place. When you start out, if you don't have scale, then it's pretty easy to deal with just looking at the service itself and just debugging it like that. But as you grow, you're going to have more and more logs and more services. And centralizing them in one place allows us to first view them comfortably, but also now we can filter, and we have all these capabilities. And on top of that, a nice UI where we can create dashboards and graphs. But sometimes it's not enough. Sometimes we need more, and in this case, we definitely need more. For example, what if we want to know how long is our service up for? Okay, this is something that we don't know right now. Or if we want to know how much memory is it using? Maybe it's crashing and we don't know about it. Or let's say we want to know how much time a simple HTTP request takes. Because if someone is trying to buy stocks and it's taking too long, then that could be problematic. This is really where metrics come into play, and that's their role. So what are metrics? At the end of the day, metrics are just numbers. They're numbers we use to represent certain information. So anything almost could be a metric. You can think about how many CPUs does the instance is using right now. That's a metric you can think of. How much memory is it using? That's a metric. Even price could be a metric in certain scenarios. So any value that's numerical. But I want to show you an example of a Prometheus metric. So a Prometheus metric contains, first, a metric name, because we need something to identify it by. It contains a timestamp, because if we have metrics, but we don't track when they happened, that doesn't really help us much, does it? For example, if we know that the service was down, but it was down for only 2 seconds, is that something that we really care about? We also have labels, and labels are also a crucial part when it comes to metrics. So if you're just tracking a metric on a simple basis, let's say, for example, HTTP request duration. In itself, does that metric help you? Well, not really, because you could have one bad API that takes a lot of time, and that one bad API will change the metric for everything else. So we need to add labels, and in this instance, to solve this problem, we need to add a route label. This way, we can actually group it by the route and see which specific routes take time. And you can think of more and more labels we can add here. For example, one more label we can add is maybe the method. We want to know if it's a GET request or a POST request. So those are metrics. On the screen, you see Grafana. That's exactly what we'll be setting up. So by the end of the second pillar, we should have something like this looking up. Let's first take a look at the infrastructure that was added. So the first thing that was added was Prometheus, which is the time series DB we use to actually store all the metrics. Then we added Grafana, and we use Grafana to visualize those metrics. It kind of has a similar relationship to Elastic and Kibana. And then we added Alert Manager. So Alert Manager works with Prometheus, and that's how actually we can get alerts. This is what we added in the infrastructure level, but let's take a look at what we added in the application level. We have a file called Prometheus.ts, and I wanted to make this simple, so all we've added is this library called Express Prometheus Middleware. And what this does is, it's an Express middleware, and by using that, we automatically get metrics for a lot of the Express requests, and for different Node.js metrics that it collects by default. So we have it right here, we use it in the app, and that's pretty much it. If you do that, you have automatic metrics set up. Of course, you can create custom ones, and we do have an example of custom ones here that you can create. But let's see what we got only from this automatic setup. So I'm going to go to my browser now. OK, and the first thing that I want to show you is that now the library exports a new route called /metrics. And what it does is that it exports all the metrics to that route, and then Prometheus will go over that route and scrape all those metrics so we can later visualize them. So we can search any of these metrics in Prometheus. If I go here, for example, we see the HTTP request duration seconds bucket. I can search for it here, and it will be here. But still, that's not something that helps us much. So how can we actually add a dashboard, start visualizing this, start seeing those metrics live? All I've done for this presentation was to shamelessly take this dashboard right here and use it. And from this specific dashboard, the result we've got were this. So all of this Grafana dashboard that you see here with tracking the CPU, the memory, different things about the Node.js service itself, and different metrics about Express, such as the request count, response latency, error duration, all of that we got automatically from the library installed, from the middleware installed. And we can keep adding more and more and more. So it's nice, right? We have graphs, but besides the looking cool, what else can graphs do? Well, because we have metrics right now, and metrics are much suited for things like trends, now we can set up alerts on those metrics and start being proactive. So what I've done is that I set up a simple alert, and I'm going to share the alert definition. So the alert we have is defined in Prometheus, and we define a simple instance down alert. So the expression it evaluates is if up is less than 1. It accepts a query language called PromQL, so you can create alerts using that. And this specific alert just makes sure that if the up metric is less than 1 for over 10 seconds, we want it to alert for us. So if we go back to Prometheus and look for the up metric, because the service is up right now, you will see it's at 1. Once it will be down, it will be at 0. Now, because it takes a few minutes to actually trigger, then I won't show you how it triggered itself, but I will show you that we can get notifications firing to the email and everything just by setting graphs. And now we get the ability to track about key performance metrics that we care about, or operational metrics that we care about, or pretty much anything. And the thing is, you can take this to your own world. Which metrics do you care about? And I'm sure there's many alerts you can think of that could help you become more proactive. For example, if the disk space is over 80%, you probably want to have an alert for it. And you can continue on and on and on with these examples, but sometimes that's not even enough, because when you have graphs and you have alerts and you're tracking trends, and let's say, for example, you're tracking the HTTP request duration, and suddenly it went down below the threshold that you defined. So let's say, for example, we want to say if X amount of users experience slow requests for this amount of time, and we see this alert popping up, what can we do now to actually improve the situation? We can't do much from going from graphs to a solution. And this is really where tracing comes into play. So tracing helps us track specific user journeys. Unlike logs, which track events, and we can look at those events, or like metrics, which track trends, tracing allows us to look at specific user journeys and look at each point there. So if, for example, we have these 4 functions calls, we have A, B, C, and D. And B also calls Postgres. We might have a metric tracking the duration of all of them, but we don't know which is the bottleneck here. When we add tracing, this is what we'll see. So we'll see the exact millisecond each and every one of them took, and we can also see some context. So it's not only about performance, but in tracing, you can actually include logs and add more context. Now, it's pretty easy to find out what the bottleneck here. Obviously, the problem is not with Postgres or not with the communication between A to B. The problem is between the communication between C to D. And now we can easily solve it. So let's see an example of how that works. And this is what it's going to look like by the end when we have Yair set up. OK, and I'll start by talking about the infrastructure that we set up here. So all we had to do to actually add tracing is to add one image, which is the Yair image. So I added that one. And we also have a new database image. So we use it for Postgres. Postgres is not something you need if you need tracing infrastructure, but I added it to show you how well tracing can work well with Postgres or any kind of database of your choice. So that's what we added on the infrastructure level. Now let's talk about what we added on the application level. So if I go to core and tracing TS, there's a lot of code here, but the important thing is first we added the Yair exporter. So we're taking all the tracing that our Node.js service will collect, and we're exporting them to Yair. And the second important thing is all the auto instrumentations here. We have Node auto instrumentation, HTTP instrumentation, Express, and Postgres. By doing that, we automatically get tracing for all of these things. And that's all you need to do if you want to set up automatic metrics for your service. Now, in the orders controller, what I've done is I went ahead into the service itself that we have, the service file here that's being called, and I actually added some database queries here. So if it fails, I'm purposely failing some query here. So I'm purposely looking for a table that doesn't exist. And if it works, then I'm just inserting some new row to a table. Let's go to Yair and actually see how that looks there. So I'm going to go to Yair. And here we can see all of our different services we have. We set up Stockley. I can click Find Traces. And now I can see all the different requests that we made. Now, we see a lot of requests here for metrics. It's a route we don't really care about. So let's filter it out by order route. So we have post, order stock. And now we can see all the different requests that we made to the order stock. So we made this 15 minutes ago. Is the one that I showed you right now on the screen. I'm going to make some new ones, actually. So just a few ones that will work. And I'll make one that fails. OK, now we can see those traces up. So first thing I want to show you is how a successful request looks like. So if we go here and we look at some successful request, we see we have a trace and we have a lot of spans. So you can think of spans as like paths within a trace. So we have all these things happening in the middle that maybe before we were never aware of. We have this middleware being called, we have the JSON parser taking a certain amount of time, and we can see that even the insert, we can see the exact time that it took, and we can also see the insert query itself and what it did. So it's pretty nice. You can look at existing requests that you have and see what's working fast and what's working slow. But the power of tracing, I feel like, comes from how easy it is to actually track specific errors that you've got. So if we look at this error, for example, we can see exactly that it failed, and we can also see where it failed. So we can see here that it failed on the Postgres level. And if we go here right now and we look at the tags, we can actually see the full statement. And sorry, it's right here, actually. And we should be able to see also the description of the error, everything that went wrong. This way, we can debug it easily. So not only we get the time, we also get the exceptions. And one cool thing you could do is actually you can add custom traces and custom spans. So what I did is that I went into the controller that we have here. I started a new span, and then I set a new attribute for that span, and a new status, and then I ended that. And I wanted to do that because I wanted to add more metadata to our span so we can debug it easily. Now, if we see this request and see placing order failed, it's not just random. We can actually go to the placing order stock, which is the custom span, and in here we'll be able to see the full log with the user, with the order, and everything else. So you also have full context. So we started by adding logs to our service. We used ElasticSearch and Kibana, and we saw that once you have logs and everything is in a centralized place, it's much easier to debug. You also have filtering capabilities, which you can use to investigate and add more context from whatever you need. Then we added metrics. We saw that logs sometimes are not enough, and we want to track key specific metrics and things that we care about. We used Grafana to visualize it and Prometheus. And then we added traces. So we used Yair to send the traces, and we saw how we can pinpoint on specific user journeys and user paths to see the exact problem. Now to conclude, I want to go back to the first statistics that we saw, if you remember that. We talked about how companies that use observability had 60% more products or revenue streams. And I want to ask a question. I want to ask why. Why did they have 60% more revenue streams or products? You could argue that the reason they had 60% more products or revenue streams is because they solved issues faster and they found issues faster. So it makes sense. They have more time, they can probably code more. But I would argue that one more reason, at least for that, is confidence. Because when you have observability in place, and you know that even if you have a bug, you will be able to find it really fast. And chances are that you'll be notified about that bug way before the customer will even see it. Then as a developer, that gives you confidence to move faster, to enjoy your work more, and to feel better about your software. So if there's one thing I can leave you here with, if there is one main point, is designing with observability in mind, and thinking of observability not as something that we want or is nice, but something we actually need for our services to operate properly. That's it. My name is Yair Cohen. I also have a blog, borderlessengineer.com, and a YouTube channel. If you want to contact me for anything, feel free to do that. And if you don't want to set up everything yourself here like you saw, we do everything ourselves in CoralLogix and more, so feel free to check it out. That's it. Thank you so much for coming.